Having a baby should be one of the happiest and most fulfilling events in one's life, but sadly this is not always the case. In the UK, around 10% of pregnancies end in miscarriage, whereas others are associated with poor growth of the baby, or the mother develops a dangerous condition known as preeclampsia when her blood pressure goes very high. Many of these complications are associated with abnormal development of the placenta, a remarkable organ that interfaces between the mother and her baby. A new placenta develops at the start of each pregnancy, and for 9 months takes on the functions of many organs in the baby that are either immature or non-functional, such as the lungs, the liver and the kidneys. It also secretes a wide range of hormones which have a very powerful effect on the mother's metabolism and physiology. My particular area of research focuses on how placental development and function are influenced by the oxygen supply, and in particular how the placenta adapts to a low oxygen supply due to poor maternal blood flow. Only recently have we realized that there's no significant blood flow to the placenta during the early phase of pregnancy, typically the first 8 to 10 weeks. Up to that point, all the nutrients necessary are supplied by the glands lining the wall of the uterus, secretions which in other mammals are known as uterine milk. When the maternal blood supply to the placenta does start, the oxygen concentration rises threefold. This poses a major challenge to the placental tissues, as oxygen is a highly reactive gas. Just as copper and brass will tarnish with time, so biological molecules are susceptible to oxidation. This can cause loss of function of molecules and even death of cells, a condition that we know as oxidative stress. This is a placenta that was preserved after a normal delivery. This surface faced the baby, and with the umbilical cord attaching near the centre, and the blood vessels that connected to the baby radiating outwards. The other surface was in contact with the wall of the uterus and penetrated by the arteries coming from the mother. Inside the placenta are a whole series of finger-like processes which have a surface area of about 10 square meters and contain over 500 kilometers of capillaries. This brings the baby's and the mother's blood into close contact, which is very good for oxygen exchange, but they don't actually mix. This is very important as it allows the baby to develop in its own environment, protected from the effects of the mother's female hormones, which would otherwise cause problems for the development of boys. Once one appreciates our total dependency on the placenta before birth, it is not surprising that it is revered in many cultures, often being considered a guardian angel or a twin of the baby and afforded special ceremonial rites. And it is this central importance of the placenta to reproductive biology that is the focus of the Centre for Trophoblast Research, a unique research hub which brings together about 20 independent research groups in the University of Cambridge and Abraham Institute, all with an interest in placental function. These interests range from the genetics and epigenetics of placental development, through developmental biology, immunology, transport and cardiovascular physiology, metabolism, through to the epidemiology of clinical complications of pregnancy and the identification of biomarkers. The centre is unique in that, to our knowledge, it is the only research facility focusing exclusively on placental biology. The shared goal of the research groups is to improve women's health and pregnancy outcomes through a sound scientific knowledge of maternal-fetal interactions, and hopefully ensure that more pregnancies result in a happy outcome.